All right, let's dive in. You're prepping for that big technical interview. You know the data structures question is coming. It always does. Today, we're going to absolutely master one of the most classic ones out there and build the perfect answer together for the linked list. Okay, picture this. You're in the hot seat. The interviewer leans forward and hits you with that exact question. Your heart might start pounding a little bit, right? Well, by the end of this, you are going to have a crisp, confident, and most importantly, correct answer ready to roll off your tongue. Let's build that answer right now from the ground up.
Every great answer starts with a rock-solid foundation. You don't just jump into the complicated stuff. Nope. You start with the fundamental building blocks, because that shows you understand it from its very core.
So, the absolute smallest piece of a linked list is something called a node. It's simple, but you have to nail this definition. Think of it like a little box. It's got two parts. First, it holds some data, the actual information you care about. And second, it holds a pointer, which is basically an arrow that says the next box is over there. That's it. Data and a pointer to the next one.
So what's a linked list then? Well, it's just a chain of these nodes. One node points to the next, which points to the next, and on it goes. But here's the first crucial detail you have to mention in an interview. Unlike an array, these nodes are not sitting side by side in your computer's memory. They can be scattered all over the place, connected only by those pointers, like a connect-the-dots puzzle.
So, we've got the definition down. Check. But that's only half the battle. This next part, this is the real core of your interview answer. Just defining a linked list isn't enough. The real test is showing you understand why it even exists. And the best way to do that is to put it head-to-head with its main rival, the good old array. And this right here shows you the key difference perfectly. An array is like a tightly packed city block. All the houses are right next to each other in a nice, predictable order. A linked list, because its nodes are scattered, is more like a chain of secret spots across a city. Each spot just gives you the address of the next one. This single difference in memory layout is the source of all their pros and cons. And that difference in memory translates directly to performance. Because an array is one big block, grabbing an element by its index is instant. That's what we call O of 1. But for a linked list, you have to start at the beginning and follow the chain. That's O of n. Now flip it. Look at inserting something at the start. For an array, you have to shift every single element down, a really slow O(n) operation. But a linked list, it just rewires the first pointer. That is an instant O of 1 operation. That right there is the fundamental trade-off.
So I keep talking about this pointer rewiring. What does that actually look like? It sounds complex, but it's actually incredibly slick and efficient. Let's visualize exactly how these super fast insertion and deletion operations really work.
So to insert a new node at the very beginning of a list, that crazy fast O(1) operation, it's just 3 simple steps. First, you create your new node. Then you tell your new node, hey, your next pointer should point to what used to be the first node. Finally, you just say that the list's official starting point is now your new node. That's it. No shifting, no copying huge amounts of data, just a couple of quick pointer changes.
Deletion is all about bypassing a node. Now, finding the node you want to delete might take a while. That's an O of n search. But once you find the node right before the one you want to get rid of, the actual unlinking is instant. You just change its next pointer to skip over the target, pointing it to the node after the target. And just like that, the node is out of the chain, effectively deleted by changing a single pointer. Okay, we've covered the basics, the big trade-offs, and the mechanics of how it all works. Now let's distill all of this down into the perfect, concise answer. This is your cheat sheet for that big interview moment. So, when the interviewer asks, explain a linked list and when to use it, here are your 3 golden talking points. Number 1, you define the structure. It's a chain of nodes, each with data and a pointer. Number 2, you explain the memory. The nodes are stored non-contiguously, which is the key difference from an array. And number 3, you nail the big trade-off. It's fantastic for frequent insertions and deletions, especially at the head, but it's bad for random access, which is where arrays totally shine. Nailing these 3 points shows complete and total understanding.
And look, if you deliver that answer clearly and confidently, you've absolutely passed the test. But if you want to leave a truly lasting impression, be ready for the follow-up. Think about what we've just talked about. What's the one limitation of a singly linked list that a pointer going in the other direction might solve? Now that's a topic for another time.